In this video, we're going to look at rates of reaction and look at factors that affect the rates of reaction. The rate of reaction is the speed at which a chemical reaction occurs, and it can be measured in a variety of different ways, and these aren't the limited amount of ways. You can measure by the change in either the mass of the product or the reactant. You can measure the change in pH. You can measure the change in conductivity, because if there's ions being produced, the conductivity will change. You can measure the change in color or the intensity of color. You could measure the change in temperature or even the production of gas. So according to the collision theory, or the collision theory is how we describe how reactions occur. According to the kinetic molecular theory, particles are always in motion, and molecules will bump into each other as they move about in the system. And if the collision leads to a reaction, it's known as an effective collision. So in this example, a hydrogen molecule bounced into a chlorine molecule, and an effective collision did occur because we ended up with 2 molecules of hydrogen chloride. Over here, the hydrogen and the chlorine bumped into each other, but it didn't lead to an effective collision. They didn't strike each other at the right energy or the right force, so the bonds weren't broken and reformed. So there are many factors that affect the number of effective collisions that can occur. We'll take a look at those over the next few moments. So the first factor would be concentration. So the higher the concentration of the reactant or the product, the higher the chance of effective collisions, and thus the higher the rate of reaction. So in this example over here, there aren't very many reactants involved. But over here, in the same volume, there are twice as many reactants. So the likelihood of there being successful collisions is higher. So surface area, if the surface area to volume ratio increases, the rate of reaction will increase too. And that's because there's more surfaces for the reactants to interact with. So if you had one big block of something, you could only interact right at the edges of the molecule. So there aren't very many surfaces available. But if you chop this into 4 blocks right here, and then you would increase, there's more surfaces to interact on all over the place. But if you broke these into 4 each, then you have all these surfaces. So the more ground up the reactants are into smaller particles, the more likely there will be effective collisions, so the faster the reaction rate. When you increase the temperature, you increase the kinetic energy. The molecules are moving much more quickly, so there's going to be more effective collisions and a greater reaction rate. Now in biology, when we learn about enzymes are proteins, so there's a temperature that will actually cause proteins to denature. So in biology, increasing the temperature will increase the rate of reaction, but only until a point in which the increasing temperature will then cause harm to the protein or the enzyme. But in chemistry, we can follow the rule that increasing the temperature increases the rate of reaction without fail. With pressure, if you increase the pressure, the kinetic energy of the reactants increases as well, so that's going to speed up the rate of reaction. So if we take a look here, this container has a plunger on the top. So right now it's not pressed down, so the pressure is relatively low. But if we push that plunger down, we're increasing the pressure and we're forcing those molecules closer together, so they're more likely to bump into each other, so the reaction rate will increase. Another factor that affects the reaction rate would be state. The state that reactants are in impacts the reaction rate as well because of the movement of particles. Solids, the particles can only just vibrate in place basically, so they will have slower reaction rates than that same substance in liquid or gas form. So reactants in the gas state would be the fastest reactions because those molecules are not being held together. They can move freely amongst the system and can bump into things because they're moving much more fast than a solid or a liquid form of the same substance. The final thing we'll talk about is the presence of a catalyst. So catalysts are chemicals that we say they speed up chemical reactions without being used up by themselves. And we say they do this by lowering the activation energy. That's kind of a lie. They actually provide an alternate pathway. So they don't lower the activation energy. They just provide an alternate pathway that has a lower activation energy itself. But we'll spend more time when we talk about activation energy in a separate video.